Hey everyone, welcome back to the channel. Are you ready to dive into something that's about to completely reshape the landscape of AI? I'm talking about how we're moving from a world of isolated, bickering AI agents to a collaborative, superpowered ecosystem. Think of it this way. Right now, most AI agents are like toddlers in separate playpens. They can do amazing things individually, but they can't share their toys, let alone build anything together. It's frustrating, right? But what if I told you there's a solution emerging? A new stack that's going to connect these agents and unleash their true potential. Get ready, because this is a game changer. This is about to change everything. Are you ready to find out how we can finally end this AI fragmentation? Let's start. Before the internet had HTTP or email had SMTP, chaos reigned. Custom integrations, fragmented systems, and brittle workflows were the norm. Sound familiar? That's exactly where AI agents are today. They're powerful, capable, and multiplying, but they don't work together. One crunches data, another drafts code, a third automates CRM. But they are isolated, siloed, and completely unaware of each other. It's like having a team of brilliant scientists who refuse to share their findings. What a waste. This is the problem we need to solve if we want to unlock the true potential of AI. Think about the early days of the web. Imagine trying to navigate without a standard protocol like HTTP. It would be a nightmare. That's the situation we're in with AI agents right now. We need a common language, a set of rules, that allows them to communicate and collaborate effectively. Without it, we're stuck with a bunch of isolated bots that can't work together to solve complex problems. It's like trying to build a house with a bunch of carpenters who speak different languages and use different tools. It's just not going to work. So what's the solution? Well, that's what we're going to explore in this video. We're going to dive into a new stack of technologies that promises to bring order to this chaos and unlock the true potential of AI agents. Are you ready to see how it all fits together? Let's go. But that's starting to change, and a new stack is emerging to support this next layer of the internet. This isn't for humans browsing websites, but for autonomous agents collaborating across systems. Google's Agent to Agent, A2A, Anthropic's Model Context Protocol, MCP, Apache Kafka, and Apache Flink. These are the four pillars of this new foundation. Let's break it down. First, we have Google's Agent to Agent, or A2A. Think of it as the universal translator for AI agents. It's a protocol that allows them to discover each other and communicate, no matter who built them or where they're running. Second, there's Anthropic's Model Context Protocol, or MCP. This is all about giving agents the ability to use tools and access external information. It's like giving them a set of instructions for how to interact with the real world. Now let's talk about Kafka. Apache Kafka is the backbone of this whole system. It's an event-driven communication fabric that ensures reliable and decoupled coordination between agents. Think of it as the central nervous system that connects everything together. And finally, we have Apache Flink. Flink is the real-time processing engine that enriches, monitors, and acts on the streams of agent activity. It's like the brain that analyzes the data and makes decisions based on it. Together, these four technologies form a powerful stack that can transform the way AI agents work. They provide the infrastructure needed to move from disconnected bots to dynamic, intelligent agent ecosystems. But why is this so important? What problems does this new stack solve? Let's dive deeper and find out. If the hype is right, and it's looking more like inevitability than speculation, most companies won't just deploy one AI agent. They'll deploy dozens. These agents will write code, triage support tickets, analyze customer data, manage onboarding, monitor infrastructure, and more. But today's tooling isn't ready for that future. The problem isn't just that agents are isolated. It's a broader ecosystem fragmentation. Agents don't talk to each other. Each agent runs in its own sandbox. The CRM agent doesn't know what the data warehouse agent just discovered. The support agent can't respond to the same anomaly that the monitoring agent just flagged. Think about it. Your CRM agent is blind to the insights that your data warehouse agent is uncovering. Your support agent is completely unaware of the anomalies that your monitoring agent is flagging. That's a huge problem. It means that your agents are working in silos, duplicating effort, and missing critical information. Tool usage is brittle and bespoke. Without a standard for invoking tools or external APIs, agents end up with hard-coded integrations and non-reusable logic. It's like every agent has to reinvent the wheel every time they need to use a tool. This is incredibly inefficient and makes it difficult to scale your AI deployments. Frameworks lack consistency. Different agent runtimes use different models. Some treat agents like chatbots, others like directed acyclic graphs, DAGs, others like recursive planners. There's no portable execution layer or shared state. We're building as if agents live in notebooks. Most agents today are designed like one-off prototypes, linear, synchronous, and ephemeral. But real systems aren't notebooks. They need to handle retries, failures, coordination, logging, and scaling. That requires infrastructure. No backbone for collaboration. There's no event bus, no shared memory, no traceable history of what agents did or why. Everything is locked in direct HTTP calls or buried in logs. As the 12-Factor Agents project argues, agents need to follow cloud-native principles. They must be observable, loosely coupled, reproducible, and infrastructure-aware. But today, most are built as brittle scripts, stitched together by hand, and assumed to run in isolation. The result? Silos, duplication, fragility. This is the mess we're in right now. But don't worry, there's a light at the end of the tunnel. The solution isn't to shove all agents into one monolithic platform. It's to build a shared stack, a new foundation based on open protocols, event-driven architecture, and real-time processing. Agent-to-agent addresses part of the problem by giving agents a common protocol for discovery and communication. But to go beyond toy demos, to reach the scale and reliability production systems demand, we need more than protocols. We need infrastructure. The agent ecosystem today looks a lot like the early web. Powerful systems, each doing useful work, but siloed and incompatible. Just like browsers once struggled to talk to servers without a standard protocol, AI agents today can't easily discover, communicate, or collaborate with one another. Google's A2A protocol is a bold attempt to fix that. It's not another agent framework. It's a universal protocol meant to connect any agent, regardless of who built it or where it runs. Just like HTTP standardized how websites communicate, A2A defines a shared language for agents. It lets them announce capabilities via an agent card, a JSON descriptor that declares what an agent can do and how to interact with it. Send and receive tasks through structured interactions, using JSON RPC, where one agent requests help and another responds with results or artifacts. Stream updates with server-sent events, SSEs, enabling real-time feedback during long-running or collaborative tasks. Exchange rich content. Files, structured data, and forms, not just plain text, are all first-class parts of A2A messages. Stay secure by default thanks to built-in support for HTTPS, authentication, and permissions. What makes A2A promising is that it doesn't try to reinvent the wheel. It builds on decades of Internet protocol history, just like HTTP and SMTP did, by leveraging familiar, battle-tested web standards. That makes adoption easier and integration faster. But A2A is only one half of the picture. Anthropic's MCP tackles the other half, how agents use tools and access context. MCP standardizes how agents invoke APIs, call functions, and integrate with external systems, essentially, how they think and act in the world. A2A, on the other hand, defines how agents talk to each other. If MCP is about giving agents access to tools, A2A is about giving them access to each other. Together, these two protocols offer a blueprint for a connected agent ecosystem. MCP powers individual agent intelligence. A2A enables collective intelligence. And just like HTTP and SMTP didn't succeed in isolation, they required adoption, infrastructure, and developer tooling. A2A and MCP will need an ecosystem to realize their potential. But even with standardization like A2A and MCP, a fundamental question remains. How do these agent communications scale effectively across a complex, dynamic enterprise environment? Relying solely on direct, point-to-point connections defined by these protocols creates its own set of challenges, particularly around scalability, resilience, and observability. This leads us to the need for a robust underlying communication infrastructure. Imagine running a company where every employee can communicate only by sending direct, one-on-one messages. Need to share an update? You have to message each person individually. Want to coordinate a project across 5 teams? You're stuck manually relaying information between every group. Now imagine trying to scale that to hundreds of employees. Chaos. That's exactly what happens in agent ecosystems built on direct connections. Every agent must know who to talk to, how to reach them, and when they're available. As the number of agents grows, the number of required connections grows exponentially. The system becomes brittle, hard to manage, and nearly impossible to scale. A2A and MCP give agents the language and structure to communicate and act, but language alone isn't enough. To coordinate dozens or hundreds of agents across an enterprise, you also need infrastructure for how those messages move and how agents react to them. That's where Apache Kafka and Apache Flink come in. These are the secret weapons that will transform your AI agent deployments from a chaotic mess to a well-oiled machine. Are you ready to see how they work? Let's dive in. Let's get down to the nitty-gritty of Kafka and Flink. Apache Kafka is a distributed event streaming platform originally developed at LinkedIn and now part of the Apache Software Foundation. It acts as a durable, high-throughput message bus, allowing systems to publish and subscribe to streams of events in real time. Kafka is used everywhere, from financial systems to fraud detection to telemetry pipelines, because it decouples producers from consumers and ensures data is durable, replayable, and scalable. Think of Kafka as the central nervous system of your AI agent ecosystem. It's the highway that all the data travels on, ensuring that everything gets to where it needs to go, reliably and efficiently. Flink, also an Apache project, is a real-time stream processing engine. It was designed from the ground up for stateful, high-throughput, low-latency event processing. Where Kafka handles the movement of data, Flink handles the transformation, enrichment, monitoring, and orchestration of that data as it flows through a system. Together, they form a powerful duo. Kafka is the bloodstream. Flink is the reflex system. Kafka gets the data flowing, and Flink makes sure it's used in the right way, at the right time. It's a match made in heaven. But how do these technologies actually help with AI agent collaboration? Let's take a closer look. Just as A2A is emerging as the HTTP of the agent world, Kafka and Flink form the event-driven foundation that can support scalable agent communication and computation. They solve problems that direct, point-to-point communication can't. Decoupling. With Kafka, agents don't need to know who will consume their output. They publish events, e.g., task completed, insight generated, to a topic. Any interested agent or system can subscribe. Observability and replayability. Kafka maintains a durable, time-ordered log of every event, making agent behavior fully traceable, auditable, and replayable. Real-time decisioning. Flink enables agents to react in real time to streams of events, filtering, enriching, joining, or triggering actions based on dynamic conditions. Resilience and scaling. Flink jobs can scale independently, recover from failure, and maintain state across long-running workflows. This is essential for agents that perform complex, multi-step tasks. Stream-native coordination. Instead of waiting for a synchronous response, agents can coordinate through streams of events, publishing updates, subscribing to workflows, and progressing state collaboratively. Let's break this down with an example. Imagine you have an agent that's responsible for monitoring your website for security threats. When it detects something suspicious, it publishes an event to Kafka. Another agent, responsible for incident response, subscribes to that event and automatically kicks off a process to investigate and mitigate the threat. This all happens in real time, without any manual intervention. That's the power of Kafka and Flink. They enable your AI agents to work together seamlessly, responding to events as they happen and making intelligent decisions on the fly. In short, A2A defines how agents speak. MCP defines how they act on external tools. Kafka defines how their messages flow. Flink defines how those flows are processed, transformed, and turned into decisions. It's a complete solution for building a collaborative and intelligent AI agent ecosystem. Protocols like A2A and MCP are essential for standardizing agent behavior and communication. But without an event-driven substrate like Kafka and a stream-native runtime like Flink, these agents remain stuck in isolated interactions, unable to coordinate flexibly, scale gracefully, or reason over time. To fully realize the vision of enterprise-grade, interoperable AI agents, we need 4 layers: protocols, A2A, MCP, to define the what; frameworks, LangGraph, CrewAI, ADK, to define the how; messaging infrastructure, Apache Kafka, to support the flow; real-time computation, Apache Flink, to support the thinking. This is the new internet stack for AI agents, a foundation for building systems that are not only intelligent, but also collaborative, observable, and production-ready. Let's put it all together. A2A and MCP define the rules of engagement for AI agents. They tell them how to talk to each other and how to use tools. Frameworks like LangGraph, CrewAI, and ADK provide the building blocks for creating and deploying these agents. They give you the tools you need to turn your ideas into reality. Apache Kafka acts as the central nervous system, connecting all the agents and ensuring that messages flow smoothly between them. It's the glue that holds everything together. And finally, Apache Flink provides the intelligence, processing the data in real time and enabling agents to make smart decisions. It's the brain of the operation. Together, These 4 layers form a powerful stack that can transform the way you build and deploy AI agents. But what does this mean for the future of AI? Let's explore that next. We're at a pivotal moment in the evolution of software. Just as the original internet stack, protocols like HTTP and SMTP, and infrastructure like TCP/IP unlocked a new era of global connectivity. A new stack is emerging for AI agents. But instead of humans navigating pages or sending emails, this stack is built for autonomous systems working together to reason, decide, and act. A2A and MCP provide the protocols for agent communication and tool use. Kafka and Flink provide the infrastructure for real-time coordination, observability, and resilience. Together, they make it possible to move from disconnected agent demos to scalable, intelligent production-grade ecosystems. This isn't just about solving engineering challenges. It's about enabling a new kind of software where agents collaborate across boundaries, providing insight and action flow in real time, allowing intelligence to become a distributed system. Think about the possibilities. AI agents working together to solve complex problems, automate tedious tasks, and create new and innovative solutions. This is the future of AI, and it's closer than you think. But this vision won't realize itself. We need to build it openly, interoperably, and with the lessons of the last internet revolution in mind. So the next time you're building an agent, don't ask just what it can do. Ask how it fits into the larger system. Can it communicate? Can it coordinate? Can it evolve? Because the future isn't just agent-powered, it's agent-connected. Thank you for joining me on this journey into the future of AI. Don't forget to like and subscribe for more insights into the world of artificial intelligence. And let me know in the comments what you think about this new stack and how it will impact your work. Until next time, stay curious and keep building.